Hello, everyone. We are going to get started. I'm going to present Standing on the Shoulder of Giant Dogs, a Kubernetes attack graph model. And basically, it's a work we have been working with the team and presented mostly around the tool called Hound. So first, I'm going to introduce myself since we are going to spend the next hour together. I used to be a pen tester for 10 years. Now I shift a little bit more about the engineering side. I'm the team lead of the team called Adversary Simulation Engineering, where we mostly develop security tooling to handle Datadog scale. If you didn't realize, I'm French. Already apologize for that. So the work I'm going to talk is not my work, it's really the work of the team. So I want also to introduce them. Jeremy Fox used to be on the team. He sadly went away to Oracle pretty recently, but he was the main lead tech around the project. And Edward, I will not say his last name because that's still too complicated, even I've been working with him for the last 2 years, but Edward is also a repentant pen tester and is also part of the team and of the project. So this is the agenda. It's pretty big, but it's like really short section. So first I'm going to do some introduction around all the knowledge and taxonomy that we need to have in order to fully understand all the presentation. So first, I would like to know who is aware of Kubernetes technology, who done some, okay, and who is on the red teaming side of it. So so most blue team people, I guess. Okay. So I'm just gonna go over a few basic keyword that is necessary for this presentation. So first, Kubernetes cluster. So basically, Kubernetes is a pretty new, I would say, technology around container, which has been around for quite a few long time. It allows basically to have this high scaling capabilities and also try to ship containers. So, but what is a container? So container is really a sandbox environment, but it's what's never built for security. It was really born to ease the life of developers so they can actually ship easier, a faster application into it, and it's one of the main abstraction around Kubernetes. The other one, which is pretty important, it's pod. It's a small class deployment unit in the Kubernetes world. It's really designed to basically handle and leverage all the container, with namespace, storage volume and everything, and all the pod are actually put together with a node. Node, it's what's closer to real machine, so it can be either virtual or physical machine, but it's basically handle all the CPU on the memory or the storage for where the container is actually running. And grouped together, you got a cluster, a Kubernetes cluster. So if you put that again together, we have the container is inside a pod is inside a worker, or the node, and all the node basically give you the Kubernetes cluster. Usually the cluster are based on the cloud provider, but this will not be the subject of the talk. We are really focusing only on the Kubernetes environment world. So if there is any assumption that I will talk about Kubernetes and not AWS or GCP or any other main cloud provider, it's only Kubernetes environment. So, okay, Kubernetes is fine. Now we're just going to do some rework again on taxonomy against basic, Kubernetes security. So first, every application is running under a container. So the first thing that an attacker actually want to do is try to escape from it, basically to try to get more privilege than is supposed to be. So that's what we call container escapes. That's one of the main Kubernetes security flows that an attacker is actually looking for. The other aspect is around Kubernetes identity, because everything, all container use a service account that are link to the container, but you can also have user and groups that give you access to the Kube API and allow you to do stuff. And this stuff is basically based on Kubernetes role and role binding, but let's keep it simple and just say it's role. And from the role, you can actually have permission to do sometimes some powerful stuff. So we put some examples. So the secret list is one of them. It's pretty obvious. You can list secret from a specific namespace, from specific resources or pod exec and so on. And the last part, it's a mounted volume. So why there is a specific focus on the mounted volume? Because it's a pretty also well-known attack path to actually do some container escape, do some other stuff. So this is why we do a specific focus, and also it is on the Hound tools that we will talk a little bit later. So if you take the schema we had previously and put it together, the container has some identity. From the identity, you can escape through walls, and to container, you can escape to the node from some volumes, or container to pod, and so on. So there are a lot of other attacks. That's not the subject of the talk. We could do like a full 1 hour just to talk about all the Kubernetes attack, but this is not really the purpose of this talk. So why is the purpose of this talk? It's basically to try to solve this problem. So let's say you have two vulnerability. So container escape number 1 on the left and container escape number 2 on the right. Okay, so are they equal? Right. Basically, how can you judge from one another? And that's where you need the vulnerability context. So, for example, on the left, I have like a privilege container that is internet facing. This has no audit, and this privilege is not needed. And on the right, I have like a controller plane DNS, which has high capabilities, but it is necessary because basically what's a core module from Kubernetes. It is needed. So how can you actually try to do this context at scale? That's something that takes a lot of your time, and that's not something is actually easily feasible. So if we play a game, for instance, and assume we have like this cluster, when we have like all of those, I would say, misconfiguration, container escape, privilege escalation, and so on, and I ask you, how secure is it? Well, basically, it's going to be hard to you will not be able to give me a grade because you don't have the context around it. And that's really what we want to do. It's try to get this context. And to get this context, we really want to have this think in graph and not in list. So this is a quote by John Lambert, which is like a really high person in the Microsoft Security Research Organization, and he did it like in 2015, so it's pretty old, but attackers think in lints and defenders think in lints, and attackers think in graph, and as long as this is true, attacker win, and we took this really to the letter. So to do that, we really try to have, this security posture, but from a graph point of view and not from a list point of view. So the old way used to be how many vulnerabilities you have in your cluster, how many misconfiguration, how many CVE. That's basically the basic question that we often ask to get KPIs around those. But the new way is more like, okay, but from them, how many are public facing? How many can have like the most impact if I want to actually patch some of it? Like where is the priority and which one can actually lead to a critical attack path? And I will come back to that later. That really what does it mean, like this critical attack path thing. So you need to measure the current state. That's one of the objectives, but you also need to measure changes over time, like have a snapshot and compare it to another one to see if your cluster is actually improving or is it going on the opposite direction. And that's something that we want to try to tackle. The other one is scale, because Datadog is like really, really, really big. I've been working for 10 years in consultancy before joining Datadog, and I never saw like such a big environment. So if you have to do it the traditional way and do like manual pen testing for every one of the cluster, it would take like years and we'd not even be able to cover all of them. So it's something also that we actually want to tackle. It's like how to do it at scale. So I'm going to try to do a demo to show you like some matrix security posture. So let's pray with me. because, you know, demo always never syncs. So, I'm going to deploy a little cluster, Kubernetes cluster on my machine with a bunch of vulnerable stuff. We come back to that later. And I'm going to also spin up the backend of Hound, which is mainly some, you see like a notebook, GraphDB, StoreDB, but I will also come back to that later. And then when everything's right, so I need to fill the time right here, we will like run Hound, and this should not get as long as it is right now, because yeah, I wanted to have like the full demo effect with everything. So you can see that I'm actually not cheating. So here we go. We take all the user have been created. So now I need to have this backup being spin up. Come on, Docker. Here we go. So now I'm going to run Hound. It's already been set up. So I already put like the kubeconfig stuff to be able. So here what it does, it just like asks the Kubernetes API to retrieve all the stuff that I need, the identities, the role, the container and everything. And now I'm going to show you like a dashboard. So don't judge me on it. I'm not a front-end dashboard. Sorry. It is what it is. But it just was made to show you like the capability. So this was done like pretty recently, to be honest. It was one of during the dry run, someone said, "Oh, you should do that." I'm saying, "Oh yeah, but you know, it's like in 2 days." I'm like, "Oh, okay." So, basically we did like some, quick dashboard around it. So here it's like loading all the statistics I need, to actually have the KPIs around that. So around endpoints, volume, containers, some global statistic. And there is the last one, identities. There we go. And from here, you have like this really nice dashboard. So, for example, it's like you can have like distribution is really like, you have to think it's like an example. It's like, you can do whatever from it. It's really simple Python script. So we have like 320 entities, so that's a really, really small cluster. And we need 2 hops to get to cluster admin from one of those entities. And overall, we got like a 52% rate. So if you land on any of the entities, you get like 50% chance to actually be cluster admin, which is like pretty bad. So if we go to endpoints, like all of the endpoints are actually vulnerable to critical attack paths, which is bad again. But that's, you know, that's made on purpose, and don't be afraid. It's not like that in data log. So same for containers. Here it's like to simulate some supply chain attack. You can, you know, assume, which one, but you need like 3 hops to get to cluster. You also get the list of everything that is being concerned by these attacks. And if I may choose scroll, identity is the same and volume the same. And of course, you can see like some obvious one. We mount the root directory. So of course, there's going to be issues there. But you see, so basically, this gives us the ability to actually manage to do some quantify the security posture. And once you have that, you can do it over time. You can do it in snapshots. But again, I will show you how the tool work and everything, and you can really build what you want to monitor. That's really the thing about it. So the solution to this problem. So you got a sneak peek out of it already. So first, I'm going to talk about graph theory. So, well, it's not going to be any financial advice from graph theory. It's most, you know, how to have relationship between objects. That's really the main thing. That's really what we want to do. So, again, I'm sorry. I'm going to do some taxonomy here just to be here. We are all on the same page. So a graph, what is a graph? It's like represents a relationship between complex objects, and here it's like limited to one cluster at a time. Vertices have like, you know, entities you have. So in Hound, it's like containers, pods, role, node, permission set. I will come that to a little bit later because that's a custom thing on Kubehound, identity and volumes. Edges is relation between those objects. And every time you link an object to another, it means there is like an attack you can actually do. So example, if you link container to a node, usually it's a container escape. And the other one you have pass, and pass is really, the output of everything linked together. And what we really want to do, usually it's get to like cluster admin. That's the main purpose. So if we take everything together, but again, we got a vertex, the edges, and if you link more together, you get a pass, and that's really what we want. So why Kubehound? Back in the day, we didn't really have any tool, at least open source, that were actually doing this kind of stuff. And we really want to have this capacity of like visualize attack path. And that's really the thing that we wanted to be good at. So also, I guess for most of people here know what Bloodhound is from, the tool from SpectreOps. We really was a game changer in the Windows industry. So we say, well, why not do the same for Kubernetes? So of course, if you, for the name, Kubehound, Bloodhound, well, we just stole it. And that's really wanted to reapply, the same thinking, out of it and to try to have like this treasure map being built up. So in our world, like I was saying, entity is like an abstraction, but in Kubehound. So sometimes we need to create our own abstraction, and permission set is one of them. It's basically a combination of role and role binding, because those can be really a nightmare in Kubernetes when you try to enter those. Critical asset, it's an asset where you actually, when you have it, we say it's over. It's like it's game over. It's like it's what you want. It's the grade. It's what you are looking after. So for now, it's only specific role like cluster admin. But I'll come to that later. It can also, we hope to update it so we can have more way to customize it. And critical path is basically a path where it leads you to this critical asset. So it's like you start from an entity and you finally get to this critical asset, and this path is what we call the critical path. And the last one, like I said, we got edges, which is called attacks in our model. So like every container escape is an attack in edges. Now, so if I translate it back again, we got, for instance, all the endpoints. The endpoints are linked to container. So this is where we bend the model a little bit. So we got this endpoint exploit. It just means that endpoints are linked to containers. There's not like real attack, but So we got identity assume. So here it's nothing related to AWS. It's like we call it identity assume. I'm sorry for all the AWS fan, but it's just you can assume an identity. It's like basic. And if you link everything together and we go to like the critical asset on the right, we get our critical path. So if you read it, it's like endpoint outside of the cluster is being exposed. From there, you can actually get an identity. And from this identity, it's like overprivilege, and you get cluster admin and full compromission of the cluster. So, we all say like, good defense is, best defense, a good offense. So Kubehound is, this like attack graph model, where we try to link everything together, so graph queries, and the main thing you have to think is if any of the entity is linked to these critical assets, and it is like reference, in our attack, it will get linked. There's like no chance you can like miss it. Everything is linked, and with sample queries, you can actually identify where it is and try to pinpoint where it is. Of course, it's a snapshot at a specific time. So it does take some time. So for example, if you dump like a 20K container cluster, it's going to take a few seconds, minutes, but we call it like a snapshot at one time. So it is what it is. So we showed it a little bit in the demo. Basically, Kubehound collect all the info from the Kube API. From there, it compute all the attack paths in a database. And from there, we ingest it into like our graph database. And then later on, you can actually trigger and use and visualize all those attack paths. And the goal is to get like from the left side to the right side, because basically when you build all those paths, it really gets crazy pretty quickly. And even here on the left, I have to limit. And this is from the the cluster I just showed you. So just imagine if you do the same on like a 20K container cluster, well, it really gets messy pretty quickly. So the goal is really to pinpoint where the security failures are, but where the important ones are, and that's really what we want to do with Hound. So we are going to do a little bit also, a little bit more in depth, a showcase of like how to pinpoint those and how to leverage Hound. So first, I'm going to talk a little bit about the user experience, because we are using a language called Gremlin, because we are using Genus Graph. Does anyone know Gremlin? Wow, I need to see you after, because I might have some question. Yeah, basically it's like, it has been written by one guy, academic one, so that's really great, that's really powerful. So when we try like play with it, we're like, well, that's super cool, we can do a lot of stuff. But then it's got a little bit harder, and we're like, oh, that's like really, really hard. But still, we managed to actually try to do some stuff out. But we are like, okay, if we can't manage to do it, and by spending a lot of time, how can you guys actually use it? And you will not want to use it because it's like really too complicated. So we decided to develop a DSL over it, so a domain-specific language over the Gremlin. So basically wrappers that can actually ease your life and make this into this kind of situation, where it's, easier, even though like on the left it can be tricky sometimes, but that's really the goal, to try to ease your life and try to have a better user experience. So we put everything on the website. I will come back to this a little bit later, but we try to describe all the DSL, so you can see the DSL where is it? Here. You can see all the DSL here, run step, critical. So we have like description around it, how to use it. We try to have like the most obvious examples that it can actually help you, and everything. But also, you have to think we are like mostly back-end guys in the team, and front-end kind of scarce. So, we just like push front-end on the side and say, well, we're just going to use something from someone and we'll be fine. So that's what we did first. We used a code called g.v. Maybe you know it? Okay. But that was like, g.v is like first, it's a rich client, so you can't really put it like as a service, which is like a pain. It's not free anymore. It used to be free, but now it's it's not free. And it's really meant for developers and not for like a good user experience. For example, if you use the DSL, you had like an error in g.v. That was fine. I mean, that was normal. But how can you explain that you're actually using a tool with an error to a user and say that's normal? So, we switch it to Jupyter notebooks, which like it is easier, so we can be spawned as a service. We can share with you like some pre-built queries, and it's also highly customizable. So for example, the dashboard I just showed you can be also run into Jupyter notebooks. For some dark reason, I couldn't make it work, so I put it on the Python script on the side, and everything was working. But you could actually have done it onto the Jupyter notebook, and therefore we are not actually doing any UI stuff. So I'm gonna do another demo. So let's pray with me again. And so here so usually I shouldn't spin up I'm going to reuse the same data, because, well, I'm not going to re-ingest the same cluster. Would not really make sense. So so that's all the notebooks that we have. Of course, I'm going to use this one, which was made for this, for the conference, to give you like a proper example. So first, we are just going to get like some overview of the cluster. So like I said, that's a pretty small one. We had some issue when we tried to do the same with like a Datalog one. Way too many stuff in it. So this is why I put like a limit for instance, because if I want to graph every single critical path from any of those entities, and that's just 2,000. I don't know how much I can grow, so let's be crazy. Let's like one more really live demo. Oh, maybe I shouldn't. No, I'm fine. Okay, so, and you see, and you can get bigger and bigger, and that's, well, there's no way for a human to actually be able to use that, and that's really something that we want to tackle. And the goal is say, okay, so that's any, so what's my interest? So let's say, containers. Containers are important in the Kubernetes model, so let's try to see if there is like, any critical path. So once again, you take the container and you try to, at the end, be cluster admin. That's the goal. So we are going to try to see, actually, from containers, is it like possible? Maybe I should have put a limit here also. No, I'm fine. Here we go. Here we go. So that's all the container one. So there's no limit. So it's a little bit better, but still, if you have to go through it manually, well, that's kind of a pain. So what's more important than container? Does anyone else, like from a pen tester point of view, what will you want to try to target first? I don't know. Anyone? Endpoints. Exactly. So the goal would be try, okay, let's reduce it to endpoints, because endpoints is what is usually being exposed. So endpoints, okay, so now it's getting smaller and smaller. That makes more sense. But still, also the goal, it's not always to say in graph, because graph are cool, but here it is like, if I have to click on every single like dot and see, okay, what it is, it's going to take me edges. So I'm going to ask the list of, okay, what are my services being concerned by those critical points? And here I can get the list. I got GMX. Oh, interesting. I got like web proxy. So from a web point of view, I can be cluster. I mean, and I got like kubedns. I'm like, okay, kubedns, don't really care. It's secure, made by Google. Well, there's no way someone can actually compromise it anyway. And if I remove the kubedns, I got like a smaller subset, and I can start to actually dig at it, because if you look closely, well, just because I'm mostly used to it, but the blue one are the endpoints, and you can get from here, you get like the 3 endpoints that are actually concerned. You land on the, let me, it is, sorry about that. You land on the container, and from the container, through different, you get to the node. Okay. And from there, well, there's like a lot of crazy paths, but if we really want to cut out like the head, I would say, of the snake or the attack path, we really want to focus on this first part. And basically, I'm going to say, now just give me all the paths from those from endpoints to the node. And here you are. You have your graph. And that's like easy readable. It's really small set. So we went from like this crazy thing to this thing in a few queries pretty easily, and you don't have to be like an expert. You don't have to be like a 10 years experienced pen tester to actually be able to do these magic tricks. And that's really the power of Hound. The only thing you have to do is like Gremlin stuff, but well, you have to choose your disease. So how did this happen? So I'm going to talk really quickly about the tool itself. It's more to give you confidence of how it works and why is good reason to use it. So first, like I said, there's this collector part. The goal is to retrieve all the Kubernetes entities. Then you have the ingester part, from where you can actually build all this like graph model around it. And yes, the other one is like the builder in the graph, where you actually build the vertices and the edges. So it's like the 3 main steps and 3 main components of it. So if I do the analogy from the 3 parts, you got like the Helm chart of a Kubernetes object. From there, we put it into the MongoDB. So we just to us to be able to query it pretty easily. And from here, you transform it into a graph entity. So that's the architecture again, just like, we always say we have to, I don't know how many times, like I think 5 times, you have to hammer so it gets to your head. That's kind of the principle here. So you get collector. So collector, you ingest it into the DB. The DB you get into the graph, and for the graph you can actually visualize it. So you see, well, pretty simple. So that's what we look out of it. Last thing around it, it's safe to use. We have run it a lot of time in Datalog. We have put a lot of limitation around it. You can customize it, but that's a basic configuration. So to avoid bringing down your cluster, because if you hammer really, really hard your Kube API, your DevOps team will not be happy. So another part I wanted to talk really about it pretty quickly, it's about the development process and why. It's because we think that the approach we took can actually be repeated against other stuff. So AWS, the Vault, anything where you actually need to put some relation together. So that's pretty obvious, but first it's like research, because basically all the work that we did, it's really bring everything together, but we didn't discover any new attacks. That was not the thing. It's the opposite. It's really try to build and put everything together with the glue. Then to do a quick design from it, and then do the implementation part, where on the implementation part I have quite a fun fact that I will share at the end of the presentation. So if we take airbag, because who doesn't love airbag, of course, we take, for example, one of the CyberArk presentation when they explain the multiple way of compromising a Kubernetes cluster. And so a lot of blog article, YouTube video, we made a POC out of it. So we do some design. When we did the airbag step, we say, oh, maybe we should try to build the permission set, because otherwise it's going to be a nightmare to get all the role and role binding. And then we try to port it to the graph. So basically, it looked like a sketchy graph from here. From here, we took like to Neo4j, and then to like what you just saw in the previous demo. And of course, sometimes we really had to armor our brain because, well, it's pretty tricky, especially on airbag. So we have to test every single use case. So when we implement something, we really want to make sure that it is actually the reflection or reality. So it's, I think, maybe too small for you all to read, but it's everything that it is here. It's actually available on Kubernetes.io, but that's really like specific stuff or research we did on the role binding, for instance. And really also try to see if the model was covering everything. And for role binding, there is some gap for now, but we will then some Jira issue to, make it work. So now we have also that, but when we want to simulate, we had this issue. How can we simulate it? And because we're doing that in production, it's sometimes not the best idea. So we discover, at least I discovered during that time, the CAN cluster, which is like an easy and lightweight cluster you can deploy on your own machine, which is pretty cool because basically on my laptop right now, there is like a Kubernetes cluster running. So we use it from end-to-end attack. So like let's say end-to-end, so we like did some real attack. We went to the container, simulate to try to see if everything was working. So since it's on Docker, there is some edge cases, especially because it's like, on Docker with kernel, especially on Mac. So some of the attack, it's not working. For instance, the core pattern UMH attacks is not working, but it was mostly sufficient for what we were doing. And basically, one of the main aspects also I want to emphasize is we build a website called Kubernetes.io where it's like a wiki around everything that we managed to put out during the research. And the first one is a prerequisite. So if you want to replicate, we put Helm chart of every single attack available on it. We have other exploitation step by step. So even once again, you are not like a 10 years experienced pen tester, or you should be able to try to do it on your own cluster. Like from a exploitation point of view. There are also checks like, okay, I'm a pen tester, I land somewhere, can I exploit it? So we also put like the methodology around it to try to see if it is actually exploitable. And the last part, we put some lead to the defense, so you can have some clue on how to fix it, or some mitigation, or, the least privilege and stuff like that. Once again, everything is listed on Kubernetes.io. There's like 26 attacks so far, more in the pipe, but once again, we really want to focus on like the user experience rather than adding more and more attacks for now. But okay, now we have that, but a tool is leaving, and we were thinking that's good, but how can we make sure we are not going to break it on the next feature? Is that something I learned back in the day on the hard way? It's like everything you release something, you don't know if it actually is still going to work. So first, unit tests are pretty obvious, but it's not something what, pretty common, at least from the offensive world, because usually we are rushing time, and that's not something we took the time. So we actually took the time to make sure we really try to get to the data log standard and apply it to Hound. So I will not go deeply over it because there's plenty of documentation around it. What is a unit test? And there's like a good meme. The main thing we did was system test. And why system test is important? It's basically give us like we were pretty confident that every time we push something, everything is still there. And for that, we are leveraging the CAN cluster. So every time we add a new PR, there is like a CAN cluster being spin up in GitHub, and we ingest this cluster and run the new code from the latest PR and try to ingest it. So first, we can see every time we reach something, does it actually ingest without any error? Then we have like generated code. So basically we translate the Kubernetes configuration file into Golang code, so we can actually check if the two are actually correspond to one another. And do we have all the role or the endpoints we should have? So like I said, we are ingesting automatically every time, and then we run end-to-end tests. That meaning that we run gremlin queries against the Kubernetes clusters that is actually being ingested, and make sure, do I still have all my attack paths? Do I still have this and that? And then give us pretty good confidence that we didn't break everything. And that's something we're pretty proud of, because that's also something pretty rare, usually, in the InfoSec world, because usually it's more about, scripting, or we don't really take the time. So I promised you a fun fact, around it. So we call it when your CTO joined the party. Basically, when we developed it, we had this first goal was like, okay, first let's write a POC out of it. So at the first, it was like Neo4j, because, Bloodhound was Neo4j, so we'd say, we're going to do the same. But it took us like 10 hours to ingest like 20,000 pods, which was, not that good. 1 hour to then all the object, because we had a script bash, like the ugliest one you can think of it. And we went, okay, now let's set some, ultimate goal for what the tool should be for us, like around optimization and everything. So first was like, we want a full open source stack, because we really want people to be able to use it. Then we said, 1 hour for like 20,000 pods seems like fair enough. Basically the goal at first was really to ingest one cluster one times a day. That was for us pretty sufficient. And yeah, maybe like 10 minutes to dump everything. That was like, for the same like 25,000 pods. So we would set the standard, we say okay, and and we managed to reach it. So we were like, wow, that's pretty cool. So, and in Datalog, we have like this OKR stuff. So every quarter we say, well, we're going to do the other one. And we are going to say, we thought that, okay, we have this, since it's taking 1 hour, we're going to do XYZ. And it's like a document page, maybe 10 pages, and everyone has like a few lines, or maybe 10 lines by team, I would say. And you are the CTO, like read it and say, well, guys, you are talking about hours, but if I do like some napkin table math, it should take like second out of it. So you're like, whoopsie. So you have a guy like who actually like takes like maybe like 5 minutes to read something like 10 lines long and say, well, your performance is not that good. And you're like, and the worst, I mean, I would say the best thing in this situation, he was right. Like, we had it memory, backend optimization, tune some steps for better writing, optimize queries, optimize Kate's API, and we managed to drop it to 30 seconds. So, you have like this guy, who is, well, of course, that's why he's CTO, and he managed to really pinpoint, well, you have performance issue, and you should try to look at it. So what's the main takeaway you take from here? It's really the power of graph, allow you to do really like this pinpoint and put this context at scale. And that's really something that there is no way it can be done in list. And there is like, we see like as a natural evolution. Like, we think that there's gonna be like a lot of more graph tooling, at least, based around a lot of the different security topic. I will take the last few minutes before taking question around what vision we have for Kubernetes in the future. The first one, we really want the tool to be customized to your need and want to let you a way to be able so you can actually customize it and use it against your own environment. Because we define critical asset in our way, but you can have like a different aspect of critical assets. And we want you to be able, without pushing PR on it, also maybe put some condition in pass. Everything is like hard written in the code, and we want basically to export all those capabilities for you to be able to customize it to your own environment. Also, we think that all attacks are not equal. Some are easier, some are easier to detect, some are easier to actually exploit, some takes times, and we really want to introduce this knowledge of weight. So we can even like you can have to calculate the weight of every single attack, and you can therefore pinpoint which one is more relevant and which more maybe has more priority around it. Last one, like I showed, so the slide were done before the dashboard actually, but basically having like this dashboard capability, but in a way more sexier way, so you can show great KPIs to your leadership. So that's also something we actually want to try to do and put it for you in a easier way. So like I said, UI, reports, tailoring, and the last part I didn't talk is really try to include Kubernetes into the SDLC process. So maybe have some capability of checking 2 snapshots and seeing what have changed, but we are kind of afraid of the noise it might have between 2 snapshots, but well, that's something we really want to do. And also we really have this idea, because everything I talk right now, it's like some application you are running on your laptop, but if you really want to scale, you need to have it as a service, and also it sounds cool. And we really want to have like this approach where you have a collector you can dispatch in everywhere, and you push everything to one single component where you can actually have all the data from every single cluster. So it will still be open source, of course, and will be like the continuity of the project. Lastly, and I will end up with that, like I said, Jeremy Fox left the team, so we are looking for someone to replace him. So if you want to work on Kubernetes and other projects and get paid for it, don't hesitate to ping me and we can discuss it. And that's it for me. Does anyone has any question? Oh, yes.
Yeah, I was wondering, do you have any plans to integrate with other open source things such as MITRE, or where everything fits framework, or top of us, effective against these kind of concepts?
So yeah, MITRE actually, that's something we want to integrate, and I think there's already an issue on it because every single attack we describe has already the MITRE information. So we want to include it in a graph. So if you want to export it or try to filter out of it, we want to gives a capability to it. For the other two, I don't know yet, but yeah, we really want to try to push as many, integrate with other tool. Oh, yeah. So, yeah.
So regarding the list, today we don't describe any CISA or hardening from Kubernetes. So what I mean is there is a list of existing proposed by CISA.
Yeah.
Specific source. I don't know if you are going to integrate it to the. There is no remediation. I don't see any proposal for remediation.
Well, we have some remediation proposal here. Some of it, maybe that could be a good idea if there's like a CISA, stuff already being brought up. I mean, we just can give the link to it. I think that can be a great idea. That's really something we didn't thought of. But yeah, that could be like a good idea to actually link to the CISA resources.
Okay, if there are any other questions, I will pass the mic.
Oh yeah, over there.
Of course, it's on the website.
Thanks. Quick question regarding CI/CD integration. Have you considered using Hound within a CI/CD pipeline? Do you see that being feasible given or do you think it's going to cause performance issues?
Well, yeah, that's the thing. It really depends on how we do it, because we really need to add like the full snapshot out of it. So that's the main issue. We can't really do that with just the diff. We really need to have like the full picture of the cluster. So we don't have a solution yet. And also what we are mostly afraid is really like the diff, to get like the noise around it and really try to focus on those like really specific. But yeah, maybe we were thinking of doing like some offline analysis of the chart or YAML if it's possible. But sometimes it's like, especially in data log, it's like a lot of, heavy black box on top of it, so you don't get access easily to the hem chart that are being changed. So you need to actually trigger and talk to the API. So that's also something that we are gonna try to think. But we really want to focus first on this like user experience, and then see how we can actually leverage like SDLC pipeline integration.
Hello. Thanks for your presentation. In some red team engagement, at some point you have access to a cluster, for example, as cluster admin, so you can dump everything. And then later, for example, 7 days later, you have time to analyze the cluster, or for example, to run such a tool. Is there a way to run the tool like in already dumped cluster without access to the Kubernetes API?
So, actually there is, where is it? Here. If you, sorry. Where is the terminal? Here we go. So there's like, see case, fix, multi-import. So it's like on work in progress. But yeah, we have like now a collector that is being divided from the ingester part. So you can collect, grab all the data and rerun as much as possible, if you want. And you already have this collector. It's called the file collector, which is also already, I think we should have it. Let me check. No, maybe get to the presentation. But yeah, if I go back here to so we have the file collector. So if you provide already, like if you use a bash or Python script that is poorly written, but if you use it and you have all the file in the order that we expect, you can actually re-ingest it as much as possible. So especially like in consultancy way, where you actually ask people to dump it and then you want to analyze it at home, that's something that can be done right now, but will be done a lot more easier in the future version, which should be out pretty shortly, hopefully.
Okay, thank you. We have time for one last question.
So because you use graph, did you use some like projection with some distance we can use in graph to see, okay, which endpoint get very close to maybe some sensitive nodes, like different projection of the graph that help you also to, from this visualization, to understand, okay, which maybe some stuff are more close than you will have thought with your architecture, but looking at it, the graph, it helps these type of things?
So not at all, and this is why we want to we took like we want to take the approach of the weight thing, which is kind of the same thing, but we think like when we put weight, even especially if it can be customizable, it's like easier to actually see the model, and it can be more easy. Yeah, it's more easy to share, and that's the approach we were thinking to test. But that's also a good idea around like closest thing, but no, we didn't try yet, or even like pocket yet. If you have any question, I would be happy to answer later. Thanks, everyone.